All right. I'm back. This is Amanda Matson, and I am talking today about the basics of significance testing. And I'm trying to mix my technology here so I can scribble. So we'll see how well that works. So hopefully you can read my handwriting. So I need significance testing. Helps if I spell significance correctly. Sorry. Significance. There we go. Significance testing. So I have a population I care about. Maybe I want the temperature in Dubuque in the last century. I want to know temp Dubuque in the last century. Okay, it's a good thing I've got subtitles because I don't know if you can read my handwriting. So I want to know the temperature in Dubuque in the last century, and I am guessing that the average temperature in Dubuque was, I'm gonna go with 60 degrees Fahrenheit. And I'm gonna call that my null hypothesis. That my average temperature in Dubuque, that's a mu, is 60 degrees Fahrenheit. And so I've got it in symbols here. This is what it looks like in symbols. And I usually put an H and a 0 in front of it to say this is my null hypothesis, H naught. And that's an NaUGHT, not like nothing. H naught is that mu equals 60 degrees. All right, so that's my null hypothesis in symbols, and in words, the average temperature in Dubuque in the last century is 60 degrees Fahrenheit. And so I always have both of those before I start significance testing. So I've got the null hypothesis in symbols, and then I have the null hypothesis in words. And then the next thing I need is what if I'm wrong? And so that'll be the alternative hypothesis. Okay, so over here, my alternative hypothesis is HA for alternative. And if I'm wrong, then it's just not 60. And so the average temperature in Dubuque in the last century So the average temperature in Dubuque in the last century is not 60 degrees Fahrenheit. And this is your alternative hypothesis. So before I do any testing, I have to clearly state what I'm looking at and what if I'm wrong. So those two things have to coexist. Okay, so I have a null hypothesis, I have an alternative hypothesis. I made it kind of blindly. I haven't looked at any data, and I've clearly stated what they are. And so that's step one. Step two is I need to gather some data. I need to look at reality. I have a lot of data in CSV files over in PositCloud, and so I could be just loading a CSV into PositCloud. Maybe I have to go hunt online for a data source, but I would have to go get some data and bring it back. And then instead of doing things by hand, we have computers for that. So we'll give it to a computer. And I need to collect data. Usually it'll be in some form of CSV. for a comma separated variable, like that kind of file. So I take my data and I give it to a program. And I'm going to give it to R, which is our programming language we use in PositCloud. And so I've got a null hypothesis, I've got an alternative hypothesis, I've got some real actual data. Hopefully my data is representative. Hopefully I use some like randomness in collecting it, right? Did those good things. And I've got them. And now I say, hey, computer. So this is the end of step 2. I say, look to the computer. And the computer makes what I like to call null hypothesis land. It makes a simulation where I have this pretend world that behaves like the reality, but is centered around my null hypothesis. And so my null hypothesis was 60. So I'm going to put 60 in the middle. And then because I do a lot of simulations and then I average and I plot it like we did with confidence intervals, where I take an average and I plot it and take an average and I plot it and I do it again and again and again. I do that around 60. And so I'm going to have this null hypothesis land from simulated data. And so it's got a kernel of reality in it because it like looks at distribution based on reality, but it's mainly from these simulations, assuming that 60 is the actual middle. And so that's what our hypothesis was. And so if our null hypothesis is correct, and I do the process like we did when we're building confidence intervals where I'm like averaging and plotting, then null hypothesis land would look like what I get with my confidence interval. But that's if I'm right. Otherwise, I'm going to have reality being way different. And so once I have null hypothesis land, this is behind the scenes. Like R won't show you this graph. It just exists behind the scenes. You don't get to see it. You take your reality and then you plot it on your graph. And so I then take my sample. And maybe in my sample, the average temperature from my sample was, say, 63 degrees. And so I'm going to plot that here. Right, that was my reality. And so my reality is out here. And based on what we did before with probability and normal distributions, I've got things that like a z-score that goes along with that. I can talk about the percentage of data that's like from here and beyond. Like those are things I've got access to. I can also take the opposite, right? So if this distance is 3, if I go the other way 3, I'm at 57. I go here and beyond, going away from my middle. From here and beyond, these data on the left, I don't know why my data disappeared. There we go. So these data on the left and these data on the right are as extreme as reality in null hypothesis land. And we need to look and say, how likely is reality to happen if we were in null hypothesis land? So that's our next step. Decide the likeliness that reality happens if null hypothesis land is accurate. Okay. If you remember before, we talked about data being at least as extreme as something else, and we're talking about how far away things are. We've calculated the percentage of our data, the proportion of our data that's like here and beyond and there and beyond. We calculated those things, so we can calculate that. We'll get something called a p-value. And P for me means like probability. Like that's the thing I want you to keep in your head. And so I've got a p-value that tells me exactly how much of my data is to the right of 63 and to the left of 57, and it's a proportion. of extremeness. And if your p-value is sufficiently small, then your odds of your null hypothesis being right would also be small. And so this is your probability. Okay. And so R will tell you this p-value. It will give you that number. Sometimes it'll be a number like 2.07 e negative 13. And if you have something like that, this e negative 13 means times 10 to the negative 13 power. And so this is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I count right? So that's what this means. When I have e to the negative 13 is I'm going that many zeros over. And so the odds of this happening are tiny. Humans are generally fairly bad at understanding odds. So like if I have a 5% chance of something happening, then that means 1 in 20. And so it's like 1 in 20 times, yeah, that's kind of rare, but it's not like earth-shattering. And so this question of like how strong that is, I like to think of as an S value. And R won't tell it to you. You have to ask R to calculate it for you. Take your p-value and take the negative log base 2 of it to get your S value. And so fortunately in R, there's a command that's quite literally log 2. And then you could put in your p-value and it'll put there. And just put a negative up front and you'll get a number. This is a way of counting your probability from a different perspective. So it's like translates it into flipping coins. So if my S value or surprise value is 8, then that's like taking 8 coins, have a whole bunch of coins in my office. I take 8 of them and I drop them. And I look at the 8 coins and I say, how many, like, were they all heads or not? So the odds of dropping 8 coins, it's supposed to be an 8. We'll do that one over, 8 coins. And getting all heads. Same odds as the null hypothesis being right. If I dropped 8 coins on the table and I got all heads, I would be pretty shocked. I'd be like, nope, nope, not happening. All right, am I gonna call the newspaper? No, but I'm definitely gonna like run down the hallway and be like, yo, check this out. You have to see that I dropped 8 coins and they were all heads. And so it's this level of surprise. If S is like 2, I'd be like, it's not guaranteed to happen, but I'm not surprised. And so maybe your null hypothesis is right. Maybe it's not. When S is 2, I don't have any evidence to tell you that it's not right. But if S is 8, then I've got some strong evidence against your null hypothesis. And so I think about this, your S value is evidence against the null hypothesis. And so I can never accept a null hypothesis because I'm never like guaranteed it will happen, but I can reject it. So like if my S is 8 or 18 or 100, I'd be like, nope, not happening. And so if I can say no to the null hypothesis, then I can accept the alternative. And so in my case, my alternative jump back to the beginning. My alternative was that the average temperature in Dubuque in the last century was not 60 degrees Fahrenheit. And so those are my steps for hypothesis testing, is that I decide on my data, decide on the thing you want to know. And this includes articulating the null and alternative hypotheses in both symbols and words. Right, I need both of them. So symbols and words. So I've got the thing I want to know, I've articulated the null and alternative hypotheses in symbols and words. And then I'm going to get actual data. Right, take a sample, onto online, get your hands on actual data, give it to a program. And the program will pull null hypothesis land for you and give you a p-value. I like R and Posit Cloud because the t-test command in R will do a lot of behind the scenes tests to make sure that like your sample size is a good one. It'll change between like which behind the scenes t-test it's actually doing. Like the t-test is technically a student's t-test, but sometimes they'll like be like, well, because your data behaved this way, we're doing this test instead. So you can find out like which one it actually did when you want to look deeper. But for this level of stats, you can trust that R is choosing the right test for you. So you're going to get a p-value out, and then you're going to decide what to do based on that p-value. And so I like to use the s-value to decide what to do. And by do, I mean conclude. And then 5 is state your conclusion in words. And so I have finished my hypothesis testing. And so this is a significance testing. Here we go. This is like, even me looking at this is half legible. Hopefully the transcript is accurate for catching all of the words that I put in here. Otherwise, I can clean things up. Yeah. All right, that was significance testing as an overview in general.